first problem, this is the ignore problem. You can write something in the box just to make sure that it's there. This is more for my online class to make sure that they printed that test work page so they show their answers. So you can just write hi in that box or whatever and be done with that, okay? That's why the numbers are a little bit off on there when I keep saying 13, but it shows 14. The very first problem is a graphing problem. I'm sorry that this makes it a little bit smaller when I do this to see, but I think we'll be all right on these graphing ones. All right. So this is y equals negative x minus 5. So we have it in y equals mx plus b already. Our m is the number in front of x. There isn't a number in front of x, so that's negative 1, right? So that's negative 1 over 1. This would be down 1 because it's negative, and to the right 1 because it's the denominators, you always go to the right. My y-intercept is negative 5, okay? That is my starting location, right? We want to start here at 0, negative 5, because x is 0 when we're trying to find the y-intercept. So we go to 0, negative 5, and then we go down 1 to the right 1, and we have our graph. Unfortunately, there is a lot of graphing on this test because this is a graphing test, but we just got to do it and get it over with. So 0, negative 5, and I went down 1 because it's negative, and to the right 1. I can pull that back up if I went too fast there. I think if I click it, it makes it a little bigger when I do it that way. By the way, on the test, like you will, at the end of the test, it will tell you your score, and you can go back and look at the questions that you missed. If you like happen to accidentally graph this on negative 4 or negative 6 and like tell me, and like I can give you partial credit or some of the points back or whatever. Like if you don't reduce a fraction and it gives you a 0, I can give you most of the points back. Okay. So I do not go back and look through each one of y'all's tests individually because it would take me forever. Because it kind of loads slow. So you have to go back and review it to see if you barely missed something, and then just tell me what number, and then I can go look at it. As y'all see, as I do these problems right here, like it kind of takes like 5 seconds for it to load to the next problem, so it really takes a long time for me to go back through yours. Okay, number 3 is on our sheet, right? You do not have to show all your work on the sheet. You just need to show some of it or whatever I'm asking for. So on the test worksheet, I'm asking for the slope. So let's just go ahead and work this problem out, and then I'll go back to that so I'm not jumping back and forth. So on this problem, y equals 3/2 x plus 3. Again, it's already in y equals mx plus b, so that's good. My m is 3 over 2. This time it's positive, so I go up 3 because it's positive, to the right 2. And then my y-intercept is 3. That is my starting location. So I start at 3, and then I go up 3 to the right 2. So I started at 0, 3. I went up 3 because it's positive, to the right 2 because that's my denominator.
And when you want us to show our work in this one, would you like us to draw the graph too?
No. So Alex is going to test you on the draw and graph part. Okay. So I don't need you to draw any graphs on these problems. So all I want is a little easier for y'all because you can have your computer screen and your paper right next to you. I got to jump to different things here. So on this one for number 3, it says interpret the slope. How much does it go up or down, and how much does it go to the right? All I want you to write there is my slope was what, 3/2. So I go to interpret that. That would be up 3 to the right 2. I'm not going to ask you to. I should have you interpret in real life, as in for every 3 that it increases, it goes 2 to the right. But that's all I need. That's all I want to see right there. Yes?
Why is this class called mathematical thinking?
We'll talk about that after the test review. All right. Number 4 is also on our sheet. Number 4, it is x minus y equals -1. So I'm going to go back to this sheet. And this one I am going to work over here because it just says show your work. X minus y equals -1. It says show your work when solving for y. So I kind of tell you what to do there. I probably should delete that. I should just write show your work. So we cannot find the slope and the y-intercept on this one. So we want to make it in y equals mx plus b. So I'm going to subtract x to try to get the y by itself. And then I'm going to divide by -1 to get the y completely by itself. I need to make sure that I divide everything by -1. So this is like a -1 in front. So -1 divided by -1 would be 1x. -1 divided by -1 would be 1. So that is my answer for solving for y. You're welcome to write the slope and the y-intercept on here if you want to, but you do not have to. I'm not going to write it on here just to make sure I only have what I want to see on here. So here my y-intercept is 1 and my slope is 1, right? So my y-intercept is 1 and my slope is 1. So let's go back over here. My y-intercept is 1 and my slope is +1, right? So up 1 to the right 1. Up 1 to the right 1. So I start at 1 because that's my y-intercept, and then I go up 1 to the right 1, up because it's positive, to the right 1 because we always go to the right. Oh no. I also, as y'all are reviewing and stuff, I do, like when you, on this review sheet on my website, I have the name of the topic that it's associated with the test as well. So, but they're all in that same review. All right, so we don't need this sheet again. Oh wait, we need it on number 5. All right, let's actually go to the sheet first on this one because it talks about both of them. So number 5, it says circle the correct answer. X equals a number. Is it horizontal or vertical? It is vertical. Anytime you have X equals a number, it is vertical. Okay. Horizontal, I kind of talk about how to remember that in just a second. Horizontal, when it's Y equals a number, it is horizontal. Okay. I feel like I made a couple of these too easy on you to show your work, but that's fine. Get the easy points. So all I need you to do there is identify which one goes with which. So when we come back over here, the way to know this one is X equals 7. So if I go to X equals 7, let me just do it with this. If I go to X equals 7, if I drew it this way, it wouldn't really make any sense because then every X equal a number would be the same line. So it's got to be this way. It's got to be vertical when it's X equals a number. And what that is saying is anytime, no matter what Y is, X is always equal to 7. So like right here where I have this other point, when Y is -6, see -6, X is equal to 7. Okay, no matter what Y is, X is always equal to -7, creates a vertical line. Sorry, I know it takes a second to have this, but it's nice when y'all go back and look at it. All right, now we do not need the sheet till number 8. Okay. Find the X and Y intercept on this one. I will tell you in the last class, we got a vertical line on this one or a horizontal line. So if that happens, it is going to be none on one of them, none of them as possible. So my x-intercept where it crosses the x-axis. So that is at -4. Oh, wait, that's y right there. Make sure you don't make that mistake because it definitely switched that on the last class. It was x as a A and y as a B. So my x-intercept is at -4 and my y-intercept is at -2. And that is it. And again, just because I had this last class. If that's at 5, if I have something like this one, my y-intercept is at 5, and my x-intercept, it never crosses the x-axis, okay? Because it is a horizontal line, it never goes. So none can be an answer. The next one, I have to find my x and y intercept algebraically. 3x minus 7y equals 15. I feel like these, I need to go back and change this topic. I'll change it later. Okay. That's not correct. I did some editing of the test. All right, what was it? Now I've been talking to myself and I don't. 3x minus 7y equals 15. Okay. So on this one, to find the x-intercept, I make y be 0. So 3x minus 7 times 0 equals 15. Negative 7 times 0 just goes away. So you have 3x equals 15. Divide by 3 and x is equal to 5. To find the y-intercept, I make x be 0. Do the opposite. So 3 times 0 minus 7y equals 15. 3 times 0 goes away, so I have negative 7y equals 15. Divide by negative 7, and y is equal to, the whole fraction is either positive or negative, so it would be negative 15 over 7. Positive divided by a negative is a negative. Technically, just to talk about it for 2 seconds, the whole fraction, like that's always the correct answer, is negative. The whole fraction is negative, so it's negative 15 over 7. But since that kind of sounds like when I say negative 15 over 7, that kind of sounds like I'm saying negative 15 over 7. That's accepted as an answer because it's just the way that I say it. But 15 divided by negative 7 is the same. Those all mean the same thing, but we never write it like that because we never say 15 over negative 7. Okay, so Alex doesn't like that answer. But again, this is one of those ones where if you happen to put that in, I'd give you most of the points because I'm not testing you on fraction integers right here. I'm testing you on the x and y intercept. Or like last class, we were able to reduce the fraction. So if you put in a fraction and you forget to reduce it, like I'm going to give you most of the points. That's something to check. All right, number 8 is on my show your work page. It says show your work for the y-intercept. Maybe, if it loads. I'm not very patient. Two x minus y equals 6. I just feel like I gotta go. I'll have to edit these. What is this, question 8?
Yeah, it's question 8, yeah.
I'm gonna have to go change my headings here because I think I changed the test after I came up with the notes. 2x minus y equals 6. Is that what it was?
Yeah.
Thank you. Okay. So on the show your work, you're welcome to put the x, solving for the x-intercept and the y-intercept, but I didn't want to have to make you write super small. So we only need to show our y-intercept on that one. So x-intercept, we make y be 0. So you plug a 0 in for your y. That goes away, so I have 2x equals 6. Divide by 2, x equals 3. For my y-intercept, Okay, I'm gonna put that on the show your work page because that's what I asked for, is just one of those to show me that you get it. So it was 2x minus y equals 6. To find my y-intercept, I make x be 0. So 2 times 0 is 0. I have negative y equals 6. So to get that y completely by itself, I divide by negative 1. And I get my answer. So my y-intercept is at negative 6. My x-intercept was at 3. No, x-intercept was 3. Y-intercept was negative 6. So to graph these, I am going to just go put those on there. I go to x3. I go to y negative 6. And I have my graph. x3, y negative 6, and it makes my graph for me. There's a lot of going back and forth on this when I do this. Oh no, it didn't go. Okay. Next one, let's see, it's not on our sheet. Our next sheet is number 11. I got to talk about that too. All right, so this says use substitution. Negative 2x plus y equals 5. And negative 3x plus 5y equals 18. Okay. This one flat out tells you to use substitution. They say it because it's easier. I do not care. Get the right answer. If you want to use the elimination and addition method, you can multiply the top one by negative 5 and then add them up and do that. That's fine. We'll do that on the next problem. But I'll do substitution just because, man, I don't know if I was working this myself. I think I'd multiply it by negative 5 and do it that way too. But I hate to not show you the substitution way. Which way y'all want me to do it? Which way?
The way you do it.
The way I would do it, if it has my x's lined up and my y's lined up like this, I'm using the elimination and addition method. Okay. I'll show you the substitution, or we can walk through that real quick. Like I would definitely just take this times. I need it to be negative 5y, right? Okay. So I would take that times negative 5. And I would negative 5 times negative 2x would be 10x. Negative 5 times y is negative 5y. Negative 5 times 5 would be negative 25. And then the other one's already 5y, so I just have to rewrite it. I don't have to multiply it. So we are trying to eliminate a variable here. When the x's are lined up and the y's are lined up, I just find that pretty easy to do. So you just multiply the top one by negative 5 so that when I add these up, negative 5y plus 5y, they cancel out. 10x plus negative 3x would be 7x, and negative 25 plus 18 would be negative 7. If you do this correctly, you would only have one variable right here. If you have an x and a y, you did something wrong. Divide both sides by 7, and x is equal to negative 1. Also, Alex is very good about not giving you fractions. Okay, you can tell me if I'm wrong about that, but if you get a fraction, probably means you messed up a sign or did something wrong. So that's good, just a good way to check it. All right, once you get one answer, you plug it in. You can plug it into the top one or the bottom one. It does not matter. I'll plug it into the top one just because. Negative 2 times negative 1. Negative 2 times negative 1 would be positive 2. And subtract 2 from both sides. So y is equal to 3. So these two lines intersect at the point negative 1, 3. So So I do not care which way you do it. I'm not one of those math people that like you gotta do it my way. Like just get the answer the best way you can. All right. I don't think I want to work this problem with substitution, but because when the x's line up and the y's lined up, I think it's easier to do that. I will pause here and let you write this down for a second. This is the substitution problem that I did last class. This one is easier to do because x is already by itself. So it is easier to use substitution on this one. If you wanted to use elimination on this one, what you would have to do is subtract the x over here and subtract the 10 over here. So you'd have to move the x over here to match up with this x, and you have to move the 10 over here to match up with this one, okay? So that gets a little confusing when you got to start moving stuff a bunch. So when a variable is already solved for, it is easier to use the substitution method. So just to walk through this real quick, what we are doing is saying x already equals 2y plus 10. So we are going to take that 2y plus 10 and plug it into that x. So we rewrite it as -4, and instead of writing x, I write what x is equal to, 2y plus 10, and then it's plus 5y minus 31. So I'm just substituting in for the x what x is equal to, which is the 2y plus 10. All right, and then you just got to do the algebra from there. You got an equation with all y's in it, so you distribute the -4. You combine the -8y and 5y. So you have -3y minus 40. You add 40 to both sides and then divide by -3, and you get your answer. If the variable is already solved for, it is technically easier to do the substitution. I don't want to go too far. I want to make sure you write that down if you want to. You are welcome to use either of those methods to solve this problem, though. All right, I think most people are done writing there. All right, number 10. My goodness, is it going to freeze like every time we go to a new problem? Oh, maybe that's why. It's trying to kick me out. Okay, number 10. This one is definitely going to be easier to use the elimination method. 4x plus 3y equals 11. Whoops. -8x minus 9y equals -13. All right, on this one, you want to look at the x and the y and figure out which one would be easy to cancel out. The 4 and the -8, that looks pretty easy, right? Because if I could just make this one be +8, I could get these two to cancel out. So I am going to multiply the top one by 2 to make that be +8x. 2 times 3y would be 6y. 2 times 11 would be 22. So when I add these up, my x's cancel out. -9y plus 6y would be -3y. -13 plus 22 would be +9. Divide by -3, and y equals -3. I really want that to be red too. All right, once you get one answer, plug it in. It does not matter which one you plug it into. I'm going to plug it into the top one. No real reason on this one at all. So you get 4x minus 9 equals 11. Add 9. 4x equals 20. Divide by 4 and x equals 5. So these intersect at the point 5, negative 3. Again, if you get a fraction, it's probably something wrong with the sign or something like that. So go back and check your answer. I do want to, y'all get the benefit of being the second class, because now I've seen like 2 different types of problems. So I do want to mention like just this one right here. I guess you're welcome to write it down. You can go write it down later if you want to as well. This one we had to multiply both, okay? We had to multiply both of them. So we made the y's cancel out. So we tried to make them, it's positive 4y and positive 6y. So the lowest common factor there that we can come up with is 12. So we made one be positive 12 and one be negative 12. So to make 4 be 12, we multiplied it by 3. To make 6 be negative 12, we multiplied it by negative 2. Okay? So it is possible that you might have to multiply both equations to make it cancel out. Okay? You've just got to come up with a number that one positive and one negative. So if I add them up, they cancel out, and then you can figure out how to make those equations match that. All right. One thing I did forget to tell you on here is, in this, my online class, I've already changed it if you're listening to this on your paper, if you haven't printed it yet. But just to make number 11 not be confusing, I am changing it to number 12. I'm sorry. So if you want to write right here, it is going to be number 12. You can also put in parentheses, not the graph. I just want to see your work for number 12, but I don't want to see the graph. I don't want to make you graph something by hand. So I'm changing that to number 12 and writing not your graph. I'll do that in just a second. I just didn't want you all to think that I forgot to do something on number 11, which we're going to next. And I'm actually going to jump way ahead here for a second. So we are moving on to the inequalities graphing. Okay, so y is less than 3x plus 4. So to jump way ahead real quick, and you are welcome to do this, like especially these, like number 13 right here that doesn't have anything to do with the problem when we come across one of these. I apologize about that. I think I got off when I was making the test. So I changed some of the test around after I did some stuff, and I forgot to change this. So we are doing number 12. I'm jumping ahead to number 13, though, because it has nothing to do with the actual problem. It's just like remembering what to do, and it will help us as we do number 10 here, or number 11. The first thing, what's the 2 differences in graphing a linear equation and a linear equality? The 2 differences are you can have a solid or a dashed line. Technically, if you wrote that, I'd make it correct, but I'm going to write, for solid, you do less than or equal to or greater than or equal to. For dashed, you do less than or greater than. And for the second one, you always have to shade. That's the 2 differences between graphing a linear inequality and a linear equation. If I were a student, like as I looked through this right before the test, like as soon as I got my paper, I'd just write that one down, because that has nothing to do with the actual problem that I'm working. It's just, do you all know the differences, okay? All right, so back to this one. Sorry, I was trying to decide if I wanted to. Yeah, y is less than. Nah, we can do it. I think y'all are good enough on the graphing now that I can just do this right without writing it down. The y-intercept is 4, right? My y-intercept is 4, so I go to 4. My slope is 3, so that's 3 over 1. I go up 3 to the right 1. So I started at 4, and then I do what my slope says, up 3 to the right 1. That is my line. So now I do the inequality stuff. It is y is less than, so I am going to change it to a dashed line. If it's less than or greater than, it's a dashed line. If it's less than or equal to or greater than or equal to, it's a solid line. All right. To me, this is like a little bit of a harder one here. If you are to shade this, if it's in y equals mx plus b, you technically can just look at it and say, okay, y is less than, I'm going to shade below the line. So it should be this side right here, but when it starts to get a little more slanted, it's harder to see. So what we can do is plug in a 0, 0 right here, right? If we plug in a 0, 0, can we just think this through, or we got to plug it in? Let's see. 0 is less than 3 times 0. 3 times 0 is 0, right? So is 0 less than 4? 0 is less than 4, so I shade towards 0, 0. I shade towards 0, 0 since it is less than 4. So I am going to shade this side. Do y'all need me to write that out, or y'all good with that? I'm telling you right now, though, if you struggle with the idea of plugging in 0, 0, just look at if it's in y equals mx plus b, you can look at if it's less than, shade below. If it's greater than, shade above. You probably get it right like 90% of the time. But you can plug in 0, 0, and we end up with 0 is less than 4, which is true, so we shade towards the point. If it was false, we'd shade on the other side. Number 12, this one we have on our show our work page. Negative x minus 4y is less than or equal to 16. Oh, you know what I didn't do real quick? Sorry. Forgot to screenshot that. Anybody look at that one? What was it? Negative. Oh, back to 12. Negative x minus 4y is less than or equal to 16. Negative x minus 4y is less than or equal to 16. Okay. I do not want you to shade or show your graph, but I do want you to show this part. So to solve this, to find the y-intercept and the slope, I need to put it in y equals mx plus b. So I add x to both sides. I get negative 4y is less than or equal to x plus 16. Then I divide by negative 4. What happens when I divide by negative? I flip the sign. So since divide by negative, you flip the sign. There is a 1 in front of the x, so this would be negative 1/4 x. And 16 divided by negative 4 would be negative 4. Okay, do not forget you got to divide both of them. There's a 1 in front of the x, and you got to divide the 16 as well. So now my slope is negative 1/4. My y-intercept is negative 4. So I'm going to start at negative 4, and I'm going to go down 1 to the right 4. So I start at negative 4, and I go down 1 to the right 4. Okay. Again, if you want to jump back over here, well, wait, I guess it's less than or equal to, or I'm sorry, it's greater than or equal to at the end when it's y equals mx plus b. It's greater than or equal to, so it is a solid line. It is in y equals mx plus b, it's greater than or equal to, so that should mean that I'm going to shade above. But if we want to plug in a 0, 0 right here, it's super easy to do because negative 0 minus 4 times 0 is just 0. You get, when it's in that form right there, you always get 0 on the left-hand side. So is 0 less than or equal to 16? And that is yes. So we will shade on that side.
So the last question is extra credit, you said?
Yeah, we got one more before we get to it, I think. I'll have to make sure like Canvas is going to transfer it correctly and try to figure out how to do the extra credit, but I'll figure it out. All right, one more before the extra credit one. I think we can do this one without writing it down. So the first one, my y-intercept is 7. My slope is 4 over 1. So I go up 4 to the right 1. Everybody good with that? My y-intercept is 7, so I start there. I go up 4 to the right 1. This is a less than. It says y is less than, so I am going to change this to a dashed line. To shade it, it's less than, so I should shade below. So I probably will shade on this side. But let's plug in a 0, 0. If I have 0 is less than 4 times 0 plus 7, that would be 0 is less than 7. That is true. So I'm going to shade towards 0, 0. So we just need to remember right now that I'm shading to the right of this line, okay? The next one, I go to 3. My y-intercept is 3. It's -2 for my slope, so I go down -2 to the right 1. Start at 3, go down 2 to the right 1. It is y is greater than or equal to, so it's going to be a solid line. Again, when they start to get all like vertical or almost vertical, really slanted, it's kind of hard to tell why are greater than or equal to. I should shade above it. So let's plug in a point. If I plug in 0, 0 to that one, 0 is greater than or equal to -2 times 0 plus 3. The 0 always goes away, so it should be easy to look at. It's just, is 0 greater than or equal to 3? No. That is false. So I'm going to shade on this side of the solid line, and I got to be on that side of the dashed line. So I should shade, oh, not there, not there. I should shade right here. I have to be to the right of the dashed line and to the right of the solid line. So my shading would be that area right there. So if you plug in 0, 0 and it's true, you shade towards 0, 0. If you plug it in 0, 0 and it's false, you shade away from it. I will, just for when you go back and look at this tonight, I will write some of these out, like the 0, 0 and the checking. Like I'll go ahead and write it out underneath this so you can see what we did. Okay. The last one I have decided to make extra credit because the first one we did was easy in last class and the second one was hard. We finished the show your work page, right? The show your work page is for you to study. You can take that home. You will get a blank one on Thursday to take the test. All right, on this one, I really kind of want to do a different one of these. I already have an example of this one. This is the same one I did last class, so I am going to go do a different one of these so you can have multiple examples of it when you're looking at the test. This is the easy one that you hope you get. All right, Caitlin does an exercise program. This is the one I thought you were going to be on the test, and then it got hard on the next one. Caitlin does a weekly exercise program consisting of cardiovascular work and weight training. Each week she exercises for at least 5 hours. So remember, at least we want to do greater than or equal to. At most, we do less than or equal to. She spends at most 11 hours on weight training. She spends at most 3 hours on cardiovascular. Let X denote cardiovascular, and Y denote weight training. Shade the region corresponding to X and Y to satisfy all these requirements. All right, so we got to go back. So her cardiovascular work plus her weight training has to be greater than or equal to 5 hours because it's at least 5 hours, right? At least 5 hours. The next part is she spends at most 11 on weight training. So weight training is Y, at most 11 hours. So So at most is going to be less than or equal to. Okay. And then the last one, she spends at most 3 doing cardiovascular. At most 3 hours. So x is less than or equal to 3. Now, I'm not 100% sure, but I'm pretty sure that you will always have to include greater than or equal to 0 and less than or equal to 0 on these. You can tell me if I'm wrong. Y'all do the homework. I don't. But you cannot work out a negative amount of hours, right? So on these word problems, they almost always do x is greater than or equal to 0 and y is greater than or equal to 0. All right, so the only actual work we need to do for this one is my red one. X plus y is greater than or equal to 5. To get that into y equals mx plus b, we subtract x over to the other side. So my slope is -1 and my y-intercept is 5. I guess I can write that. Down 1 to the right 1. All right, now we got to remember all these equations as we go graph it. All right, so that one was a y-intercept of 5, and it was a slope of -1, right? So 5 and down 1 to the right 1. And it was y is less than or equal to, right? Can y'all tell me so I don't have to jump back and forth? So it should shade below if you need to plug in a 0, 0. X plus 0 or x plus y is greater than or equal to 5. So 0 plus 0, if I plug that in, 0 is greater than or equal to 5. That is not true, okay? So I would shade over here. So we need to remember that we're shading over there. Whoops, I don't want to do that yet. Now we got to go through our horizontal and vertical lines. So at most 11 weight training. Weight training is y, so I go to y equals 11. And it's at most, so I'm going to shade below that. At most 3 hours cardiovascular. That's my x. So I go to x equal 3 and draw a vertical line. At most, that means I'm going to be less than that, right? So like right now, if I didn't shade or didn't do that greater than or equal to 0, my answer would actually be over here. But that's not going to be correct because I cannot have a negative amount of cardiovascular work or whatever x is. Yeah, x is cardiovascular. So I always have to put a vertical line on the y-axis and a horizontal line on the x-axis to make sure it stays within that x is greater than or equal to 0 and y is greater than or equal to 0. So now when I go to graph this or shade it, I have to be above this line, to the left of this line, below this line. It would be that area right there. That one is super hard because there are what? Did I end up with 5 lines? Are you glad I made that one extra credit?
Yes.
Okay. So that one is extra credit. Before I'm done, I will show you. Oh, let me screenshot that before I forget. I just want to show you this one. The other one was this one right here. The hard part about this one, there's a couple hard parts about this one. And I'll probably write some extra stuff down here in just a second. But it says the foundation to be at least 4 times the amount. That makes it hard to come up with because you're doing 4 times, so you got to do 4x. But what makes this one really hard too is if you look at my axis over here, like this stuff right here, it's like 0 to 500 and 520, I guess. So you have to like plot points. You can't just do this one, like look right here. I have a slope of -1. Well, my y-axis is at 460. So if I go 460 down one to the right one, I can't hardly do that. So what you have to do on this one is plug in some numbers to figure out the answers. So like to graph this right here, it's actually easier to find the x-intercept and the y-intercept, okay? To graph this one, you can use 0, 0 as 1 point, but then you have to plug in x equals 100 or x equal 20 or whatever x you want to figure out another point. I'll kind of write that out, but that one is not fun because of the axis. So I'll do that in just a second. I think